All right, everyone. So today we're going to go over the second part of parallel lines. And so this time what we're going to do is we're given one parallel line. So quick sketch. We're given one parallel line or one line, I'm sorry. And then we're going to be given a point. We're going to try to find the equation of the line that goes through this point. So it goes through the point, but is parallel to the other given point equation that they gave us. Okay? So they gave us a line, a function of a line, an equation of a line, and where they're going to give us a point, and we're going to find the equation of that line. Okay? So let's go ahead and get started. So given a function f of x equals negative 4x plus 5, find the line parallel to the given function, but going through the point 0, 4. Okay, so what I always do is I write the function that they gave us first. F of x equals negative 4x plus 5. And then I'm going to write new line. Okay, so what we know of our new line, it's parallel to this function here, this line. And we know parallel lines have the same slope. So that means this new line has a slope of negative 4. Okay? So it has the same slope as this line here. And it goes through the point 0, 4. That's all we know. So using this information, we're going to go ahead and use something called point slope form. And what this is basically an equation of a line that is in point slope. It needs a point and it needs a slope in order to use it. Okay, and it's y minus y1 equals m x minus x1. And guess what? This right here is going to be x1, y1, and then that's your slope. So we're basically creating the new line that's going to be parallel to this line. Okay? So plug in y minus y1, in this case is 4, equals the slope m, which is negative 4, x minus x1, which is 0. Okay, let's go ahead and distribute. Y minus 4 equals negative 4 times x is just negative 4x. And negative 4 times 0 is just 0. So I'm just going to leave that. All right, I'll write it out. Plus 0. But we're going to add 4 to get rid of it on this side. And what you do to one side, you do to the other. So you have y equals negative 4x plus 4. And there it is. So let's make a copy of this here. Now they don't look exactly the same. We'll make a quick little change. So these lines should be parallel to each other. They have the same slope, but they have different y-intercepts. And that's something you learned yesterday. Parallel lines will never cross. They have the same slope, but different y-intercepts. Okay? And there you go. There's your two graphs. You can graph them from there. Now let's just double check. Negative 4x plus 5, negative 4x plus 4. And it has to go through the point 0, 4. Well, if we go to Desmos, let's see here. Y equals negative 4x plus 5 y equals negative 4x, was it plus 4? Yeah. Plus 4. Now, the point that it was supposed to go through was 0, 4. Check it out. Parentheses 0, comma 4. Yep. And it went right through it. There it is. Okay. Let's do one more. Given the graph y equals 3x minus 2, find the equation of the line that is parallel to this line and goes through the point 1, comma 4. Okay. So again, our new line has the same slope as this line, and it goes through this point 1, comma 4. Okay. So that given, let's write our equation. Y minus y1 equals mx minus x1. Let's plug in our values. This is x1, this is y1, and this is your slope. So y minus 4 equals 3 parentheses x minus 1. We're going to distribute. Y minus 4 equals 3x minus 3. Add 4 to both sides. Y equals 3x plus 1. And let's go ahead and grab this one here. And there we go. These two lines are parallel to each other. They have the same slope, but they have different y-intercepts. If you graph them, they're just going to be two parallel lines. And that was our goal. So I hope this was helpful. If you have any questions, just let me know. And I'll see you guys on the next one. Peace.